Welcome. If you're new here, don't forget to subscribe for more fascinating videos and to support the channel. There's always more to explore in the universe. What if everything we thought we knew about the laws of physics was suddenly called into question? What if, out there in the vast emptiness of space, something was moving in a way that should be impossible? NASA's latest discovery has left scientists stunned. A black hole, a cosmic monster that devours everything in its path, appears to be moving faster than the speed of light. If true, this changes everything we understand about the universe. But how is this possible? Could Einstein's theory of relativity be wrong? Or is there something even stranger happening, something beyond our current understanding of physics? For years, astronomers have tracked black holes as they drift through galaxies, invisible but powerful, warping space and time around them. These objects, formed from the collapse of massive stars, are known for their immense gravitational pull, so strong that not even light can escape. But nothing, according to Einstein, can travel faster than light. And yet, recent data from NASA's deep space observatories has revealed something unexplainable. A massive black hole, thousands of times the mass of our sun, appears to be hurtling through space at impossible speeds. If true, this would defy everything we thought we knew about physics. Is this an error in the data, or could we be witnessing a phenomenon that challenges the very foundations of modern science? If black holes can move this fast, what does that mean for the structure of the universe? And more importantly, what could it mean for us? To understand why this discovery is so shocking, we first need to look at how black holes move through space. Unlike planets, which follow predictable orbits around stars, black holes don't always stay in one place. Some are locked at the centers of galaxies, acting as gravitational anchors that hold everything together. Others, called rogue black holes, drift through space, often after violent cosmic events like galaxy collisions or supernova explosions. But even the fastest-moving black holes we've observed follow the same fundamental rule as everything else in the universe: nothing can exceed the speed of light. This principle comes from Einstein's theory of relativity, which has been tested and confirmed in countless ways. According to relativity, as an object approaches the speed of light, its mass increases, requiring more and more energy to keep accelerating. In simple terms, the faster something moves, the harder it becomes to push it even faster. At the speed of light, it would take infinite energy to go any faster, something that, as far as we know, is impossible. Every spacecraft, every star, every particle ever observed follows this rule. NASA, along with other space agencies like the European Space Agency, ESA, and astronomers using the Hubble Space Telescope, has spent decades tracking black holes, measuring their speeds and understanding their behavior. The fastest recorded black hole before this discovery was moving at around 5 million miles per hour, fast, but still nowhere near light speed. So when scientists recently detected a black hole seemingly breaking this cosmic speed limit, it sent shockwaves through the scientific community. At first, researchers thought it must be an error, perhaps a miscalculation or an optical illusion caused by gravitational lensing, a phenomenon where the intense gravity of massive objects bends and distorts light. But as they double-checked the data, the numbers remained consistent. Something was moving at speeds that shouldn't be possible. Was it really a black hole? If so, how was it moving this fast? And if we were wrong about this, what else might we have misunderstood about the universe? Inside a dimly lit control room at NASA's Jet Propulsion Laboratory, a group of astronomers sat huddled around their screens, their faces illuminated by the soft glow of data streams pouring in from deep space. It had started as just another routine observation, a team using some of the most advanced telescopes in the world to track black holes moving through distant galaxies. But then, something appeared on the screen that made everyone stop. A single data point, seemingly insignificant at first, showed an object moving at an extraordinary speed. Too fast. Much too fast. At first, they assumed it was a glitch. Space telescopes like Hubble and the Chandra X-ray Observatory gather mountains of data, and errors happen all the time. Perhaps a sensor malfunctioned, or a cosmic ray had interfered with the signal. One of the researchers, heart pounding, quickly ran the numbers again. Then again. The calculations were solid. The object wasn't just moving, it was moving at nearly the speed of light. A silence filled the room. No one wanted to say it out loud, but they were all thinking the same thing. If this data was correct, it meant one of two things. Either their understanding of physics was flawed, or they were witnessing something never before seen in the universe. As they focused in on the object, the situation became even more bizarre. This wasn't just any celestial body, it was a black hole. A rogue black hole, estimated to be millions of times more massive than our sun, tearing through space at an impossible velocity. Scientists had long theorized that black holes could be ejected from galaxies after violent collisions, but none had ever been observed moving like this. And certainly not at speeds that should be, according to every law of physics, unattainable. More observatories around the world were brought in to confirm the readings. Teams from the European Space Agency, Japan's JAXA, and observatories in Chile and Hawaii scrambled to point their instruments at the mysterious object. The data was undeniable. This black hole was real. It was moving. And it was defying the very fabric of space-time as we understood it. The implications were staggering. Had something propelled this black hole to such speeds? Was it falling through a cosmic shortcut like a wormhole? Or, perhaps the most terrifying possibility, was our understanding of the speed of light itself flawed? If black holes could break this universal limit, what else could? Could there be forces at play in the universe that we have yet to discover? The discovery had thrown open the doors to questions that scientists had never even dared to ask. And, now, the race was on to find the answers. Verifying this phenomenon wasn't easy. The numbers defied everything scientists expected, and the risk of misinterpretation was high. Some experts argued that the black hole's apparent speed might be an illusion, perhaps a trick of gravitational lensing or an unusual relativistic effect. Others speculated that the black hole wasn't moving at all, but rather space itself was warping around it in a way we didn't yet understand. The challenge was clear. If this black hole truly was moving faster than light, it would force physicists to reconsider some of the most fundamental laws of the universe. To confirm the discovery, astronomers turned to every available tool. NASA's Chandra X-ray Observatory reanalyzed the radiation signatures coming from the object, while the James Webb Space Telescope examined the surrounding region in infrared. If this black hole had gained such extraordinary speed, there had to be a reason. Perhaps it was ejected from a violent galaxy merger, where gravitational forces had acted like a slingshot, hurling it into the cosmic void. Or maybe it was being influenced by something unknown, an exotic force, a hidden cosmic structure, or even a theoretical phenomenon like dark energy. Scientists also compared this event to past discoveries. In 2017, astronomers detected a neutron star collision that sent ripples through space-time, proving the existence of gravitational waves. That finding had revolutionized astrophysics. But this was something different. If a black hole could move like this, it might mean the universe was hiding forces we had yet to understand. Could this discovery be the key to faster-than-light travel? If a natural process could accelerate a black hole beyond light speed, could humanity one day learn to harness this power? The excitement was undeniable, but so were the doubts. Was this a one-time event, or were there other black holes moving at these speeds, undetected until now? If they existed, could they pose a threat? A black hole moving this fast would be almost impossible to see coming, and if one were headed toward our galaxy, we might not know until it was too late. Scientists needed answers, and fast. The implications for space exploration were enormous. If this discovery held up, it could mean there were ways to manipulate space-time that we had never considered. It might offer clues about how wormholes work, or even hint at the existence of unknown dimensions. And if something had given this black hole such unimaginable speed, understanding that force could be the first step toward unlocking interstellar travel. The scientific community was on the edge of a breakthrough, or a mystery so deep it might take decades to unravel. Either way, one thing was certain. The universe had just become even more mysterious, and humanity was only beginning to grasp what that truly meant. This discovery changes everything. If a black hole can move at speeds that should be impossible, what else in the universe might defy our understanding? Could there be other forces at play? Unknown cosmic engines driving objects faster than light? And if so, could we one day harness that power? Scientists are already planning follow-up observations using next-generation telescopes, including the upcoming Nancy Grace Roman Space Telescope and planned gravitational wave detectors that might reveal hidden clues about what propelled this black hole to such speeds. For space agencies like NASA and ESA, this discovery raises profound questions about the future of space travel. If there is a natural process capable of accelerating a black hole to these speeds, could a similar principle be used to propel spacecraft across the cosmos? Scientists have long theorized about warp drives and space-time manipulation, but now, for the first time, they have a real cosmic phenomenon that suggests it might not be pure science fiction. More immediately, astronomers will be on the lookout for other fast-moving black holes. If this wasn't a fluke and multiple black holes are breaking the speed of light, it could mean that our fundamental laws of physics are incomplete, or that the universe is far more dynamic than we ever imagined. Could these black holes be evidence of shortcuts through space-time like wormholes? Or are they being influenced by forces we haven't yet discovered, perhaps linked to dark energy or the very structure of the cosmos itself? One thing is certain, the universe has just revealed another of its secrets, and it's one that will take years, perhaps even generations, to fully understand. But for now, one question lingers. If a black hole can move faster than light, what else might be lurking out there in the vastness of space, waiting to challenge everything we thought we knew? The discovery of a black hole moving faster than light is more than just a scientific anomaly. It's a wake-up call. For centuries, humanity has looked to the stars, believing that the laws of physics were unbreakable, that the speed of light was the ultimate limit. But what if that limit is not as rigid as we thought? What if the universe holds secrets that could one day allow us to travel the stars, not in centuries, but in moments? This moment may mark the beginning of a new era in astrophysics. Just as the discovery of gravitational waves revolutionized our understanding of space-time, this black hole could be the key to unlocking deeper cosmic truths. It challenges everything we thought we knew and forces us to ask daring new questions. If black holes can move like this, what does it mean for our understanding of space-time? Could there be other unknown forces shaping the universe? And if faster-than-light motion is possible, is interstellar travel closer than we ever imagined? One day, when humanity finally leaves Earth behind and sets sail for the stars, we may look back at this discovery as a turning point. The moment we realize that the universe is far stranger, more dynamic, and more full of possibilities than we ever dreamed. Perhaps this black hole is just the first sign of a hidden cosmic mechanism, one that, if understood, could open the doors to the galaxy and beyond. The question is no longer whether we are ready for the future of space exploration. The real question is, what other unimaginable discoveries are still waiting for us out there in the endless abyss of the cosmos? If you love exploring the mysteries of the universe, make sure to subscribe and hit the notification bell so you never miss an update. Space is full of incredible discoveries, and we're just getting started. What do you think about this black hole breaking the speed of light? Could it be the key to interstellar travel, or is there something even stranger going on? Let us know your thoughts in the comments. And if you enjoyed this deep dive into the cosmos, give this video a like. It really helps us bring you more amazing space content. See you in the next one.